As we go on to the last section of Chapter 1, we're dealing with properties of real numbers, and in our textbook it's on page 61. To start us off, we'll do a little review of this, which are some of the basic properties of real numbers. We speak of the commutative property, where if you have the order A plus B, that is equal to B plus A. That's the commutative property of addition. That is, you're allowed to reverse the terms that you have in their order, reverse them. And the same is true for multiplication. A times B is the same as B times A. That's referred to as the commutative property. Then we have the associative property, and I didn't quite set that up yet so you could see it. Here we know that A plus B plus C equals A plus B plus C. But if I put a parenthesis around here, it tells us to add the B and the C first, then add it to A. Or I could put the parenthesis around there, and this tells us to add the A plus B first, then add it to C. So this indicates that we are allowed to associate various terms, and this is the associative property of addition. Now, if I were a student, I might write this down on a piece of paper so I could become familiar with these various properties. Now, the one of multiplication is, we know that A times B times C equals A times B times C, but here it's saying we should do the B times C first, then multiply it by A, or we can multiply the A times B first, and then multiply it by C. But the results are going to be the same. Now, in the distributive property, I didn't finish this one, so I wanted to show you how it works. We are distributing, and this is addition, the A through multiplication to each of these terms. So A times B equals AB. A times C is AC. And then in subtraction, it's the same. AB minus, though, is the difference, AC. Now, in our last property that we want to go over at this time, there's one more that we'll cover later, is the identity property. Now, when you do this function, the results are the same, that is, an identity. So A plus 0 is A. So when we add 0 to any number, it remains the same. Now here we're going to multiply a number, A times 1. And we've used this before. A times 1 is A. So any number times 1 is the multiplicative identity. Anytime we add 0 to a number, that's the additive identity. So again, these are the rules. You may be familiar with them. When I taught high school algebra, we had students memorize this, and we're assuming you're going to be memorizing some of this, or through application, you'll get to know them. And now for our examples. This first one, they want us to indicate in the commutative principle, what would the results be? Well, here it would be 5 plus x. We're just reversing the order. And then here it's going to be x times 3. In example 2, we're doing the associative principle. So here we're saying we could write this 5 plus 4, add that together, then the 6. And in multiplicative principles, we could go -1 times 2 times 5. And again, associating this, and maybe commutative as well, if we switch these two around, the 12 and the x goes here, then we can go 10 plus 12 plus x. So this was like a two-stepper. We switched these around and then associated this way. Now, as you do your work in algebra or mathematics, many times we do these things automatically. So for instance, I would have picked the 12 and the 10 mentally to do this. But this is saying it is a principle of math and the results are true. And here we would say -3 times 7, put that together, and then the x. So this is going to be a -21x. But they're saying they wanted you to show how it works using the associative principle. As we do this next section, we're going to be using the distributive principle, and let's just do it. So I often think of, you're going to distribute the 2 to these. Now here you have to be careful of the sign. Negative times negative, negative times positive, and then here you have 3. Now, an interesting thing as we start here in chapter 1, that in a later chapter we're going to be doing something that's called factoring, where we factor out a common factor. So you can see in each of these two terms there's a common factor of 2. You would do that by just going back to the original. So this is in its factored form. This is in its distributive form. And again, we're factoring out, in this case, a -5 out of each of these. To multiply is so much easier. When you have to factor, it's a little creative. And the same thing here. There's a common factor of 5 in each term. Now, this next one's a good example, too, of something in which we're going to multiply what is in a parenthesis by a -1. And all that does is it reverses the sign. This will become a -2, and this becomes a positive y. So if we factored out a -1 from these two terms, we'd have our -1 out there, and then inside it would be this. A very useful technique for later chapters. Now, another way of showing that you're multiplying by a -1 is just to put a negative in front of a parenthesis. Now, we could put the 1 there if we want, but it's essentially the same. That is, we're going to remove the parenthesis and change all of the signs. So this becomes a -3, this becomes a -x, and this becomes a positive w. Again, an important rule. Whenever there's a negative in front of a parenthesis, we can remove the parenthesis and just change all of the signs of the terms inside the parenthesis. Now here we're going to multiply 1/2 times 6x. So we're going to cancel out the common 2 and get 3x. 2 goes into 14 7 times, so plus 7, plus 10. And now we're going to join these common terms, 3x plus 17. Well, if I looked ahead, I would have seen our next examples are this. This is factoring. When we see a common factor in terms, it's the reverse of the distributive process. And here we see a common factor of 8. So we factor out the 8 and we get 2 plus x. And here we see again a common factor of 7. Now we'll be using that technique in chapter 2. I put these extra ones up. Here again we have a common factor of 5. This would probably be in the form of a 15 here, but they're showing it in a very simple way. And here we're just factoring out the 9. The letter Z is tough because it looks like a 2 if you're not careful. So I usually use the cursive form. Two rules that we had mentioned earlier. The additive inverse, or is sometimes referred to as the opposites. If we have a 5, the additive inverse of 5 would be a negative 5, so that the sum would be 0. So the additive inverse is the opposite of something that when we add it to the term, the sum then is 0. Now, a word that can be confused if you're not careful is the multiplicative inverse. And the multiplicative inverse, sometimes referred to as the reciprocal, is what you would multiply something by for it to equal a positive 1. Now, what do we multiply 5 by to make it a positive 1? Well, we take this number, remember it's sort of over 1, every number is over 1, and flip it, and this then becomes 1 over 5. And then now everything cancels out, and the product of that is a positive 1. So multiplicative inverse or reciprocal, additive inverse or opposites. As we go into our last topic, what they're asking us is to say, what principle do these examples illustrate? Well, again, since we have our little code there, except for the last one, y, 3 times y, y times 3. Well, we see it right there. So that's the commutative principle of multiplication. Now here we have x79, x79. The order is exactly the same, but we're grouping it differently. So when we group things differently, that's the associative of addition. In letter C, we have a 0. Adding something to a 0 and not having it change its value, that would be the additive identity. You can add a 0 to something, it doesn't change it. So the identity of addition. Now here we have like the beginning of, well, the letters are the same, but here we see in the parenthesis they're switched around. So far, this is the commutative property of multiplication, that we've just switched these 2 letters around. Here was one we just had. When we're multiplying a number by its reciprocal, and that would be the multiplicative inverse, we said. The multiplicative inverse. In some cases, they may give you the word reciprocal. All right, here we have the opposites. Adding a number to its opposite gives you 0. And then here, this is sort of a complicated one because what we've done is we've switched the order of these two, and then the associative principle. So the commutative switches the order, and then associating them differently. Okay, well, this finishes our Chapter 1 review of real numbers. Once you get your practice and quiz-me's finished, you'll take your test. And in order to take your test, you need to have 100% on your quiz-me's. Remember, you didn't have to get 100%. You could miss one and still get mastery. We'll be starting Chapter 2